Hi, my name is Michael Began. I'm going to be doing my presentation on small bodies that orbit the Sun, like meteoroids, meteorites, meteors, asteroids, and comets. First, we have asteroids. An asteroid is a celestial body composed of rock, metal, or a mixture of both that is orbiting the Sun. Most of them are in the asteroid belt, which lies between Mars and Jupiter. Even though there are millions of asteroids with sizes up to more than 500 kilometers, they're pretty much of no danger to planet Earth. The biggest body in the asteroid belt, Sirius, is officially not called an asteroid anymore. They have changed the naming to it of a dwarf planet. The scale of the solar system is so immense that even inside the asteroid belt, the average distance between two asteroids is actually above 1 million kilometers, or 3 times the distance between the Earth and the Sun is how close asteroids are in the asteroid belt. Some asteroids have very elliptical trajectories crossing the orbits of the inner planets Mars, Earth, and Venus. The cause of these elliptical trajectories could be collisions within the asteroid belt or the gravitational influence of Jupiter changing the orbits of some asteroids gradually over time. All asteroids with orbits so eccentric that they cross Earth's orbit are called Apollo asteroids. These Apollo asteroids approach the Earth but do not cross Earth's actual orbit. Apollo asteroids are going to sooner or later collide with one of the inner planets, usually within a few million years of their orbit becoming so eccentric. The largest Apollo asteroid, 1866 Sisyphus, has a diameter of about 9 kilometers. Similar to the asteroid that caused the Chicxulub event, the giant meteorite impact that caused the extinction of the dinosaurs. Sisyphus and none of the other big Apollo asteroids will collide with Earth within the next millennia, which doesn't mean that smaller bodies can cause local damage. I'm sure some of you remember the Chelyabinsk event, which took place on February 15th, 2013 in Russia. There are several YouTube videos of this meteor actually landing down. If you have time, I would suggest looking one up. It's pretty amazing how bright the actual meteor is. There's dash cam videos of people driving that caught it on film, so that's actually pretty neat. So if you get a chance, you should check that out. Meteoroids, the technical name for a small, solid body moving within the solar system. They range in size from the size of a piece of dust to around 10 meters in diameter. Most of them originate from comets that lose gas and dust when they approach the Sun. Other meteoroids are basically smaller asteroids. There's no exact diameter that distinguishes an asteroid from a meteoroid. The vast majority of all meteoroids are just a few millimeters and less in size. The smallest and by far the most numerous ones have sizes of small dust particles and are called micrometeoroids. They do not leave any visible trace behind when they enter Earth's atmosphere. Meteoroids, also called a shooting star, is defined as the bright trail of light created by small solid particles entering the Earth's atmosphere and burning up. Most meteors that we see last only a few seconds and are made by meteoroids the size of a raisin or smaller. Most of these tiny ones heat up so much when entering the atmosphere that they actually completely vaporize. A meteor is the light that you can see when a small meteoroid enters the Earth's atmosphere. This normally happens with speeds between 11 and 73 kilometers and at altitudes of about 75 to 120 kilometers. Under a clear sky at night, you can see about 5 to 10 meteors per hour, especially after midnight when Earth has rotated so far from the observer's part of the sky is positioned in the direction of the Earth's motion around the Sun. During meteor showers, the rate of observable meteors per hour can increase significantly. Meteor showers are caused when the Earth crosses higher than usual concentrations of particles that are themselves in an eccentric orbit around the Sun. Since the orbit of these particles is fixed, we encounter the stream every year at the same time. Just its density cannot be foreseen, so we can tell when we're going to be seeing meteor showers. We just can't tell how intense they're going to be. This sometimes leads to sparse meteor showers and sometimes very intense meteor showers with more than 1,000 meteors per hour, also called meteor outbursts or meteor storms. These meteors we see can be debris from a comet, which usually they are 90% of the time or greater, or an asteroid. The most famous meteor showers are the Perseids, which is in mid-August, and the Leonids, which is in mid-November. The meteors during these meteor showers almost all emerge from the same section of the sky each year. The light path behind a meteor, what this is caused by, small meteoroids will be heated by friction until the point when they completely disintegrate. The light emission is mainly caused by interactions between evaporated and detached components of the fast-moving meteoroid and air molecules. Both the meteoroid atoms and the air molecules ionize during this encounter. When the free electrons recombine with the ionized atom in the tail of the meteoroid, they emit the light that we can observe. The light tracks can have a length of up to several tenths of kilometers and an initial diameter of a few meters. The color of the meteor is an indicator of the material of the meteoroid. A yellow color is caused by iron, a blue-greenish color is caused by copper, and a red color caused by silicate material. Larger pieces that survive this lose some of its mass going through the atmosphere, but do actually wind up touching down on Earth. A meteor that is larger and brighter than the normal is called a fireball, brighter than the brightest planet in the sky, which is Venus. Some of these trails of light that do wind up actually touching down on Earth, these are classified as meteorites. Every asteroid or meteoroid that survives its passage through Earth's atmosphere can be advanced to be called a meteorite. Meteorites are made of rock, metal, or a mixture of both, which is called a palisite. Palisites form beautiful olivine crystals that are embedded into a metal matrix. Most stony meteorites are composed of smaller, rounded chunks of rocky material stuck together. The grains are called chondrules, which in Greek means small grain. Meteorites that have a lumpy structure are called chondrites. Chondrules contain traces of radioactive material which can be used to measure their age. Some stony meteorites have no chondrules and are therefore called achondrites. They appear to have been melted and been transformed like the rock found on Earth, and therefore probably come from asteroids that were large enough to heat up and melt. Scientists are eager to study meteorites since they are the very first material that was formed in our solar system almost 4.6 billion years ago. Which brings us finally to comets. Comets are asteroid-like objects which are composed of ice, dust, and rocky particles. The sizes of their nuclei vary between a few hundred meters to tens of kilometers in diameter. Their visible tails can extend to above 150 million kilometers in length. They originate from outside Neptune's orbit and, like many asteroids and meteoroids, are unmodified remnants of the formation of our solar system about 4.5 billion years ago. When comets approach the Sun, the solar radiation and solar winds cause particles to sublimate and detach from the comet, forming a tail of particles which often makes them visible in the night sky even to the naked eye. Below the surface of a comet, there can also be reservoirs of liquid water which can vaporize and feed jets of water vapor. Comets orbit the Sun on elliptical orbits until all of their volatile materials have evaporated away. The orbital periods vary between a few years and tens of millions of years. Most notably, Halley's Comet, we can see that about every 75 years. Short period comets mainly originate from the Kuiper Belt, a region in the solar system with millions of icy bodies extending from about 30 AU, which is right around Neptune, to 50 AU. If some of these icy bodies get too close to Neptune during their orbit, they may be deflected and enter a new eccentric orbit that will make them become short period comets. Long period comets normally originate from the Oort cloud, a region between 2,000 AU and 50,000 AU, or about 1 light year away from the Sun. The Oort cloud consists of trillions of icy objects with diameters over 1 kilometer. Gravity of nearby passing stars and the galactic tide can cause these comets to sometimes change their trajectory around the Sun and approach the inner parts of the solar system. Comets from the Kuiper belt tend to orbit the Sun within the plane of the solar system because the Kuiper belt itself is aligned with the planes of our solar system. Comets from the Oort cloud can arrive from all different directions since the Oort cloud has a spherical shape. A comet's tail is caused by gas and dust particles that are vaporized by sunlight and then blown away by solar wind. The tail always streams out in the direction opposite the Sun, but it doesn't arise until the comet enters the inner parts of the solar system, somewhere between Mars and Jupiter, so that the sunlight can sufficiently heat up the comet. And to wrap everything up and just recap here, asteroids are small, generally rocky, solid bodies orbiting the Sun and range in diameter from a few meters to hundreds of kilometers, most being found in the asteroid belt between Mars and Jupiter. Meteoroids is the technical name for the small, solid bodies moving within the solar system, so while they're still in space, they're classified as meteoroids. Once a meteoroid enters our atmosphere and heats up, the trail of luminous gas it leaves is called a meteor or a shooting star. Once that meteor lands on Earth's ground, it's then classified as a meteorite, which is something that has struck down the Earth. And a comet is a small body that orbits the Sun consisting of a tiny ice core and a tail of gas and dust, with the tail only forming as it approaches the Sun. Alright, well, thank you for listening in, and I hope you took something away from this PowerPoint presentation. Thank you.